specifically studying that. But like, I kind of went back to the whole just so commercial. But, right. Yeah, all my tests were last week, and then this week, or none this week, and then this week.
Yeah.
So things that I have more time to study.
Yeah. This weekend.
I do have a, you said instruction.
No, I've done it.
Oh, I have the, second one this semester, so. Oh, really? It is really interesting.
I think we've done it on my son, and she went in.
She left, right?
Yeah, she was on Facebook.
They were doing the bone capsule next year. So I'll have that. Well, the bones kind of look like them, but I kind of have all of them.
Wait, how many classes did I want?
4 of them.
Okay, good. I can share with you.
Yeah.
So my question is, I consider them very processes because I enjoy them.
The hard part for me, because I actually got 100 on the first test. So that was kind of awesome. But for structure function 2, I have to take it during the summer. It's only doable with the Dr. Wagner actually. And I heard he's like really nice. But I heard his class.
Yeah.
So,
You what I heard, I have
yeah, I've heard a lot. But it'll be during the summer. So
yeah. For me, structure function 2 is just harder than 1.
was it harder?
It was harder.
Oh, it was harder. Gotcha.
Yeah. Because we have to memorize all. Then,
Oh, yeah.
so we took up all that shit, this structure stuff, and the operations stuff. So we have to understand the first, and then we'll completely get it, right?
Right. Yeah, like I don't know, I heard even Dr. Hicks told me, not going to it's like, it's just so much memorization. He almost doesn't memorize the text.
Yeah.
But then she said he doesn't use the text, but he's listening. I don't know. Then I had another student tell me that he basically has everything memorized. Like, he just knows. So I guess his classes, he just gets up there and starts talking, and then you have to listen to everything.
But I think my friend is saying, you use my name, you will know that to teach you.
Oh.
I think that's what we're trying.
Right.
Yeah.
Please help me. I need an A, so.
Yeah, I know, right? I didn't get A in this one, but I didn't know, so I didn't know that's what I just didn't know.
I just want to know.
Okay. First things first. I will pass around the sign-in sheet. I am working on getting Blackboard updated. I didn't realize it's been 2 weeks since I was able to update it. But what I did do is by 2 o'clock this morning, I had all of your grading done. So I'm going to pass back everything that you've turned in. The grades will be posted on Blackboard hopefully today. When I call you up to pick up your papers, go ahead and pick up one of these monster packets. I will explain a little bit more about that monster packet in a couple of minutes. So let's see. Katie. Let me make sure I have everything. It was 2 weeks. Katie Atkinson. I didn't realize I had 2 Katies. Katie Atkinson. Okay. Macy Broadway. Oh, there's the other Katie Duran. I don't know why I didn't think I did. Grab a packet. There's all yours. Mackenzie. Macy Hardwork, or Handwork, excuse me. Sam Hope. Sexy.
That's two. I was like, that really is a monster.
It's still a monster, but
Thank you.
Addie Key. Zach. Oops. Jackson. Grace. Andrea. Corey. Fingers to work. Lisa. Oops, I missed some of your one of your parts. Nora. AJ. Elizabeth. Yeah, I just haven't downloaded.
I was just gonna take the notes, so that's you.
Come grab your papers. Please. And grab one of those. Okay. So again, this should catch up with all the grading. All 3 labs are graded. The 2 quizzes that you turned in at the start of term are graded. I just need to enter them into Blackboard now. Okay, so the packet. When I taught this last, I had created a study guide. And that's what for each exam. Our material covers 2 exams from the previous thing, just like it does for this class, thanks to the snow day. So what it is it's 2 different study packets that I've combined into one packet. Now, I have posted the answer keys to this packet on Blackboard, but what I want to do right now is I want to go through the pages because there's a few problems that we're not going to get to that are in this packet. But this test is going to be stylized like this packet too. So this is giving you both an idea of how the test will be stylized, plus giving you additional practice. So as far as if you turn to page 8, it is the first set of multiple choice. Question number 13. It's at the bottom of the page. You do not need to know that question.
From the accepted mechanism.
Yes. Because we did not talk mechanisms. If you flip to the second packet, which again, we'll start with Intro to Organic and Biochem at the top of the page. And flip to page 6 and 7 of that one. This is where we get into the reactions. It's question number 16. B, you can cross out B, E, F, and H. The rest of that, all the rest of those questions are valid types of questions. But this will hopefully give you a study guide to prepare for the exam. Does this help with what you were hoping to get?
Yes. Yeah, it really does.
So that you can see how the questions will be asked. They will be stylized very similar to what you see here. And I wanted to use this because what you will notice is the program that I use to create the molecules creates them in a very specific way. And so I wanted you to get comfortable seeing how the molecules would be drawn. Andrea? Any questions for me over that? Again, I've posted the answer keys in this week's folder to both of those so that you can do them and then check your work. Okay. I'm trying to get caught up in this class, so just like everything else. Okay, so what we're going to start with is a functional group or a group that is in the next several functional groups we'll be talking about. That group is the carbonyl group. A carbonyl group is simply a C double bond O group. Now, a carbonyl group, because of the structure, which is trigonal planar, and because of the C double bond O, we will find that a carbonyl group is going to be polar in nature. This puts those aldehydes and ketones and anything else that contains the carbonyl at higher boiling points and melting points than alkanes because they are polar. The carbonyl group, the bond angles are at 120 degrees. And it is a trigonal planar arrangement. So it's very, very flat. It's basically all within, if you were to draw it, it would all land within this plane. Because it all lands within this plane, it's actually a very reactive group because it's easy to attack it from this angle. It's easy to attack it from the back. And because the bond angles are at 120 degrees, it's easy to attack it from any direction. So carbonyl groups are extremely reactive groups, meaning that we're going to see a number of reactions that these compounds can undergo. So again, the carbonyls are then divided based off of what else they're attached to. So we talk about aldehydes and ketones in one group because they have similar properties, because of the fact that the atoms they're bonded to are not polar. Carbon is nonpolar. Hydrogen is nonpolar. So everything it's attached to is a nonpolar. It is only the carbonyl group that is polarized. We then put in carboxylic acids, esters, and amides into a different category because then we have elements that can hydrogen bond. And so they're in a completely different category. So we're going to start with the aldehydes and ketones, and then later we're going to move into the carboxylic acids, the esters, and the amides.
You say later, you mean like later today or like after the exam?
After the exam. They're a separate chapter, basically. So let's talk about aldehydes. An aldehyde is going to be a carbonyl group that occurs at the end of the molecule because that carbon must be attached to a hydrogen. Now, when you see it drawn out, a lot of times you'll see the aldehyde drawn out, much like I have drawn it out, where you have the R group attached to the carbonyl group attached to the hydrogen. But when you're writing out a formula, and it's not the structural formula, when you're just writing out the formula, we do have a way to distinguish that it is an aldehyde from a alcohol. And it is found in the order that we actually write the elements, the element symbols. So if you see it written at the end as a CHO, that means that it is an aldehyde. Whereas if you see COH at the end, that means that it is an alcohol. So again, that is when you're looking at the molecular formula. That you're going to see this difference in notation. Questions about the basic structure of an aldehyde. The second thing is a ketone. Ketones are carbonyl groups where the carbon is attached to two other carbon chains. A ketone is a carbonyl group where the carbonyl carbon is attached to two other carbons. Again, because of the presence of this carbonyl group, we do have a polar compound in both cases. But they're not going to be near as polar, and they're not going to have as high of a melting point or a boiling point as an alcohol would. The reason for that is because while they are polar, they cannot hydrogen bond between two of the same molecules. So again, just a note, an alcohol or an alkane is going to be the lowest boiling point, melting point. Because all it can do is London dispersion. You will follow that with aldehydes and ketones. Which have dipole-dipole forces because of the carbonyl carbon oxygen pair. And that is going to be less than an alcohol, which has hydrogen bonding, which can hydrogen bond between the molecules. Now, if we wanted to continue this, after that, you would get into diols, which have greater hydrogen bonding. Followed by phenols. And the phenol again is stronger because once it loses that hydrogen, it can distribute the electrons that are left over around the entire molecule. questions about the general structure of the carbonyl group, the general structure of an aldehyde, and the general structure of a ketone. Okay, then we're going to move into naming aldehydes and ketones. Okay, so common names. We do have some that we use the common name for. As much, I mean, we can name it with an IUPAC name, but we do use the common name. And for aldehydes, those common names typically end in the word aldehyde. The simplest of all aldehydes has the carbonyl group attached to 2 hydrogens, and that is formaldehyde. The second is a 2-carbon aldehyde, and it's called acetaldehyde. Folks, one thing you will note, if you look back at other common names and things like that, a lot of your 2-carbon compounds have something with acid attached. Acetone is an exception, but a lot of them, acetic acid, for example, it's a 2-carbon thing. Acetylene is a 2-carbon thing. So that may help you in remembering the acetaldehyde is a 2-carbon thing. Another is when you have the aldehyde attached to the benzene ring, it's called benzaldehyde. Yes, you do need to know these compounds and their common names. This is where flashcards might come in handy, is on these common names. Now, we do have a way to name these compounds using IUPAC naming. And basically, if it's an aldehyde, we replace the E of the alkane with AL to indicate that it is an aldehyde. You number the carbons to represent the substituents, just like you always have, except this time you start with the carbonyl. So an example would be CH3, CH, CH3, CH2, C double bond O, H. The C double bond OH makes this an aldehyde? In an aldehyde, you number the carbons, starting with the carbonyl carbon. So carbonyl carbon will always be number 1. Because of this, we don't have to indicate where the aldehyde is located. It's always carbon number 1. 2, 3, 4. So our substituent is on the 3rd carbon, and it is a methyl group. This is a 4-carbon chain, which is butane. But we're going to replace the E with an Al to represent that it is a aldehyde. So this would be butanal. Let's deal with naming ketones. First of all, the common names. The very simplest of all ketones has the common name acetone. As many of you noted, acetone is a key component, or was a key component, in fingernail polish remover. Now for the rest of them, you're going to name the groups, or name the groups. Bonded to the carbonyl carbon in alphabetical order. And then you're going to end the name with the word ketone. So for example, the next simplest ketone would be a 4-carbon chain ketone. The left side of the carbonyl is the methyl group. The right side of the carbonyl is the ethyl group. So this would have the common name of ethyl methyl ketone.
So we don't need a number.
You don't have to have, you don't have, for the common name, you don't need the number. Again, this is about common names. For IUPAC naming, you number the carbons. So that the carbonyl is the lowest number possible. So for example, CH3, C double bond O, CH2, CH2, CH3. We would number the carbons so that the carbonyl is the lowest number possible. And then we would state where the carbonyl is located. And we would replace the E of the alkane with O-N-E, own. So this would be 2-penta known, pentanone.
So for the carbon names, or the, I mean, not the common names, are those just structures that we need to memorize that we need to see?
So yes, on the acetone. The acetone, I would just memorize and know this is acetone. For the others, you can derive the name because of the fact that you're just naming the substituents attached to the carbonyl. So common names can be, except for acetone, would be easy to, you should be able to derive.
So for aldehydes, they always have to be number one, right? When
Aldehyde, the carbonyl is always number one. Well, in ketones, because you got to remember, let's go back up here to aldehydes and ketones. An aldehyde always has to be at the end of the carbon chain. So it's always number one because we never label a hydrogen. But a ketone has to be surrounded by 2 additional carbons. So that puts it in the middle of the chain somewhere. So we simply number it so that it gets the lowest number possible. Does that answer your question?
So for the ethyl methyl ketone, you counted wrong if it was, like if we put like 2 butane.
So this one up here, it's IUPAC name. Would be 2-butanone. On my exam, unless I specify common or IUPAC, it doesn't matter which one you use. I will try to specify whether I want the common name or the IUPAC name. So let's look at a couple more examples. Give the IUPAC name. For CH3, CH2, 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 C double bond OH. CH3, CH2, C double bond O, CH2, CH3. CH3, CH2, CH, CH3, CH2, CH2, C double bond OH. Ooh. And I want the IUPAC name for, so you're gonna have to draw this one out first because I'm giving you the common name. I want the IUPAC name. I'm gonna give you a moment to work on those. Okay, so the very first one, it was a 5 carbon chain with, that was an aldehyde. So to do the IUPAC naming, the carbonyl is always the first carbon, so we don't have to specify. It would just be pentanal. Now, folks, if you give me one pentanal, that's fine too. But it is simply understood that the aldehyde has to be on carbon number 1. The second one is a ketone. It is a 5 carbon chain with the carbonyl carbon on the 3rd of the chain, so it's 3-pentanone. The fourth one, we had to number the aldehydes as number 1, so we number the carbons in turn. And so the methyl group is on carbon number 4, so it was 4-methylhexanal. And then finally, we had to translate the common name into the drawing. Since it's dipropyl, it means that there's 2 propyl groups attached to the ketone, the carbonyl carbon. And so it winds up being 4-heptanone. Any questions about that one? Okay, so the next one, we're going to draw the line structure. And give the common name for 1-phenyl. Propanone. Two methyl, 3-pentanone. Let's go with those 2. Okay, the first one, when you draw it out, propanone, so 3 carbons. The reason you did not have to specify where the ketone was is because a ketone has to be surrounded by 2 other carbons. So if it's propanone, there's only one place it can be. And then it's specified that on 1, it's going to have the phenyl group, which is a ring. So when I drew it out line structure wise, it would look like this, and it would be called methylphenyl ketone. Yes. Not for a ketone. That would be a carboxylic. If we had a OH group here, that would be a carboxylic acid. Phenyl, no. Phenol is an OH group. But phenyl is a term used to describe a benzene ring that is a substituent. And then this other one is more like what you're gonna see. It said it was a pentanone, so that's 5 carbons. It told me that the ketone was on the 3rd carbon, and then on the 2nd carbon in the chain is a methyl group. I redrew it as a line structure. Over here, this is the ethyl group. So that's why it's ethyl. Over here, this is the isopropyl group. So isopropyl ketone. Questions?
I was kind of thrown by like the one on the phenylpropyl.
It just meant that the phenyl is on the first, because the one always is telling you, a number preceding is telling you where that belongs. So since it's a propanone, it's saying that the phenyl group has to be on carbon number 1. So this, of the propanone, the key here is you had to start with the propanone.
Oh,
1, 2, 3 is propanone. And then you had to go and look at numbering the propanone 1, 2, 3.
right, and the carbonyl can't be 1, because like you said.
Correct.
Oh, okay, that's what they're doing.
Carbonyl is not, the carbonyl is always going to be on 2nd carbon or more
'Cause it has
in a
to be
ketone.
Oh, okay.
Now there is a there's a benzene that is a ketone, but it's and it's a little different.
So,
I'm sorry, what exactly is a phenyl group? Was it just-
A phenyl group is the benzene ring when the benzene ring is acting as a substituent. Phenyl is a benzene ring when the benzene ring is acting as a substituent. Okay, so we've actually already embarked upon the next part, which is the properties. Of aldehydes and ketones. Because I've already talked to some degree about melting points and boiling points, and it is related to their polarity, and so on and so forth. So again, because it has that carbonyl group, an aldehyde is going to be polar towards the oxygen. A ketone, because it has that aldehyde group, that carbonyl group, is going to be polar towards the oxygen. So we know that this is a polar molecule. Since there is no OH or NH bond, it means that between 2 aldehyde molecules or between 2 ketone molecules, the only force, or the force, the primary force is a dipole-dipole force. Questions about that comment? So again, since they cannot hydrogen bond, between themselves, they have lower melting points and boiling points than an alcohol and a phenol. Now, with respect to water solubility, small aldehyde and ketone molecules will be soluble in water because they can accept hydrogen bonds, hydrogen bonding from the water. Basically, what happens is, again, you have this carbonyl carbon that is, and remember that it is polarized towards the oxygen. What happens is the hydrogen from the water molecule will be attracted to that carbonyl oxygen. Or in the case of a ketone, again, it is still polarized. And so the oxygen from the ketone can be attracted to the hydrogen in a water molecule. But this can only occur if the lower portion is a small molecule. Once the R groups become large, since they are comprised of carbon, they become less soluble. The only other thing that I will say is ketones tend to be less toxic than aldehydes. Any questions? That is where we're leaving it for exam number 1. Well, what was exam number 2, now exam number 1. That will give you there was a few questions that I had marked that I had to look at this morning to see if we would go over. And now everything that I did not have you X out on this is valid. So you can come look at mine or get with somebody. Any questions for me? I will update the website today with the 2 lectures that I don't think have been added to it, which is Tuesdays and today's, or 3, I don't know which, but it'll get all updated today, so that you have everything to study for this exam. I am not going to get started into the next piece because that way we have a clear-cut definition of where the exam ends. Yes.
And then Monday we're doing the alkene or reactions.
This is not due to next month, not the company, but somebody else.
Oh,
I cannot remember. I will specify it on the Blackboard, because I can't remember what we're supposed to work on.
right.
I think we start the reactions lab, but again, we don't finish the reactions lab because we're not through with all the reactions. So I may have to delay even further when it's due,
Right.
dependent upon when we get to all the reactions that it is describing. No, that is not something you'll have to do before lab. I probably will go ahead and lecture as part of the lab since it is a dry lab, and we will be in 105. I always, instead of sitting on those uncomfortable chairs, we'll sit in 105 for the dry labs. And so I'll go ahead and get that book today too. Any other questions for me? If you want to see the answer key to I have the answer key here for the alkane dry lab where you did the isomers. You're welcome to come look at it. And if you have other questions, I'll gladly answer. But otherwise, we are good to go.
Why?